Welcome to Penn State Scranton. We're so thrilled to see all of you here. Thank you for making time to join us for this event and program. My name is Marwan Wafa. I'm the Chancellor of this wonderful campus of Penn State University. It is an honor to be part of Penn State University, which plays a significant role in many aspects of Pennsylvania. And of course, we could not do this without wonderful, capable faculty, which we have here also with us. And of course, the impact that the graduates make in our community, whether it is local, state, or national. Penn State University, Penn State Scranton, we are one of 24 locations. And I don't want to complicate that to you because we are a complex organization. But we are the local Penn State University. This is a commercial, by the way. And I didn't know this until I joined Penn State because I was with Indiana University. During my interview, I got stuck with one issue until a colleague of mine who retired did this thing to me. I said, okay, I blew it. And I didn't understand that we are really one university, which means that when I shake hands with the graduates in May, they get a Penn State University diploma. Not the case in Wisconsin where I was, or Indiana where also I was, where it states the location. I mentioned this to you because many people don't know this reality. So if you are from Pennsylvania, you have no excuse to know this, okay? So if you have children that are at the age or approaching going to the university, let me talk to them, and you will not regret that. Again, we're so pleased to see all of you here for this, I think, critical program. I was talking to some of you earlier. We are all in need of learning how to make use of artificial intelligence in being more efficient, effective, not to be intimidated or scared by it. So ignorance is the worst enemy of human beings, so it's important to learn that. I'd like to acknowledge some of the key people who have been instrumental in making this event today possible. I'll start with Krista Schneider. There she is, this young lady. She is with PennTap, and she's a technical advisor, and she will tell you more about what PennTap does, right? Of course, Don Webster. Don Webster is the executive director of Tech Bridge, and are you going to talk about that a little bit sometime later?
Absolutely, yeah.
And of course we have John Drake. He's standing way back there. He is the director of what we call it CBITCO because it's a long name, Center for Business Development and Community Outreach. And he also will share with you, I think, the value of what the center at Penn State Scranton provides. Customized training and so forth. So I'm not going to take that on of you. So I hope that today's event will be worthy of your time and commitment to be here, and I look forward to bumping into you sometime in the near future. So welcome to Penn State Scranton, and enjoy the rest of the day. Back to you, right?
Yes.
All right. Take care. Thank you.
All right, can everybody hear me? All right, just real quick, a few things about PennTap, just so you know. This is my commercial. My role is technical advisor, Pennsylvania Technical Assistance Program. We are a program that's within the Office of Industry Partnerships. We help spur economic development in the region by connecting businesses and industry with the resources of Penn State. And so I am the technical advisor for Northeast PA. You can see number 3. Those are all my counties. I work out of Penn State Hazleton, but I serve all the campuses and the counties that you see here. So if you are a business or industry and you're looking to connect with Penn State, of course, John is your first point of contact, but I help bridge that gap as well. So my role in this forum is to basically just tell you that we exist. And the reason that I helped organize this event is because I felt it was very important to help bridge these gaps and build bridges between business and industry in Northeast PA with all the resources of the university. And so I will stop at that. We are a grant-funded statewide organization, and if anybody here that has manufacturing facilities or has a business that they want to connect with me, I have my cards out and I am happy to speak with you after. So I'll leave it at that because I know we got a lot to discuss. I just want to say thank you very much to the our hosts, of course, Dr. Waffa and John. Don is going to facilitate today, and we have 4 wonderful speakers that Don will introduce here in just a minute. This forum series is the 3rd of 3 that I've hosted. The first one was at Penn State Hazleton that focused on energy technologies and transitions. The one back at Penn State Wilkes-Barre focused on the semiconductor industry and Mid-Atlantic Semiconductor Hub initiative that Penn State is involved in. We want to focus today on artificial intelligence. The whole purpose of this is to figure out how Northeast PA can play a role in each of those really critical industries and technologies that are evolving as we speak. And so that is your assignment today, is to think about how you and Northeast PA in general fits into this future. Okay, thank you.
So good morning, everyone. My name's Don Webster. I'm the executive director of an organization called TechBridge. TechBridge is a regional organization. We focus on entrepreneurship and innovation. And so the first thing that I'd like to do today as your facilitator is let you know that there's still food outside. If you would like to get up, if you need to go to the bathroom, out through the back door will always be open. You can always come back in. My other job as a facilitator is I'm the gatekeeper. So at TechBridge we talk about we start on time and we end on time. So what we're going to do is we're going to stay on time today. If you just take a second, just look around at all the people that we have here today for a second. I mean, it is really great, and I think you're going to really enjoy the program. You gave us the gift by coming today, and I really mean that. I mean, this is a great turnout, and I think we're going to have some really interesting conversations. But the gift that you can give back to Penn State and PennTap and the speakers is to think about the questions that you want to ask them. That is, with all the great things they're going to talk about, the best part of these conversations are when you guys ask questions about things that are important to you. So I'm going to encourage you to write questions down. We are going to ask you if we could have the questions at the end, just so that we can stay on time. But we really want to create some conversation. There is going to be a break, and we are going to have a tour at the end. So if you would like to see this great facility, that's one of the things that we're hoping we can accomplish today. Okay, so we are going to start with our speakers. And if you have any questions, you can grab me at any time. There is going to be a break. So let's do this, okay? Sandra, are you ready? All right. So our first speaker this morning is Dr. Sundar Kumara, and he is the Alan E. and Alan M. Pierce Professor of Industrial and Manufacturing Engineering at Penn State. He also has an affiliate appointment with the School of Information Sciences and Technology. Dr. Kumara serves as the director of the Center for the Applications of Artificial Intelligence and Machine Learning to Industry, also known as AIMI. His research interests include artificial intelligence and machine learning applications in manufacturing and healthcare, sensor-based manufacturing process monitoring, yes, that's a mouthful, data science, graphic analytics, and large-scale complex networks. Dr. Kumara is among the first to have worked with artificial intelligence in manufacturing from an industrial engineering perspective. Throughout his career, he has conducted applied modeling and implementations through research projects for companies including GM, GE, Ford, and most recently working with Geisinger Health Systems to help with the intervention on high-risk patients after surgical discharge. Dr. Kumara will be speaking this morning on what is Industry 5.0, what is artificial intelligence, and what is artificial intelligence doing for small and medium-sized manufacturers. Dr. Kumara.
Good morning, everyone.
Good morning.
And thanks for being here. And I got lost in the morning trying to come from the parking lot to here. So I have a close friend in Pittsburgh. He always, when we are driving together, when I'm in the front passenger seat, he would ask me which direction I should go. This is before our GPS and Waze and all that stuff. I would tell him right, he will always take left. And then he's always right. So, thank you. And that's a lot to cover in, where are the slides? Yeah, okay. Yeah, a lot to cover in 20 minutes. I think he said I'll kick you out at 20 minutes. So, I think, yeah. I'm going to give you a glimpse of a few things. I'm not here to tell you what AI is or what deep learning or what machine learning is. Can you hear me at the back? Yes. Yeah. So if you look at AI in general, you have deep learning as one of the what you call lower ends, and then you have the neural networks before that. You have machine learning, and then you have knowledge-based systems. If for those who followed AI in the early 80s, you used to have rule-based systems or expert systems, and those are all knowledge-based systems. And then you have the general structure of artificial intelligence, which has problems of planning and, like for example, robotic path planning. You have thought, like problem solving, which is search as a basic mechanism. The foundation of AI is that every problem is a search problem. Whether you are coming, like for me, coming from the parking lot to here, it is a search problem. Because I did not use my phone. I was just using the paper, which also proved to me I could not read it well. Therefore, I had to change the way I'm reading, and therefore there are different possibilities I explored. At least I explored 3 possibilities. And I think there are about 2 steps to go. I went both, came down and then tried figuring it out, and then there is a search problem. So the premise is almost all problems are search. The algorithms help you to navigate through this search. And all those algorithms can fall into any of these things. When you go to neural networks, they are 20 years back or 30 years back, they were like poor persons or poor man, woman, or whatever you like to call them. Person's brain's representation on the computer system. Whereas today, with deep learning, you can have like trillions of nodes, and then you can do, when you go to large language models, you can have trillions of nodes, which will try to solve a problem, which can be both in the language-based structure as well as the regular algorithmic structure. So, and then you can immediately see when you have so trillions of nodes, the power that would be needed to do this is going to be super high, extraordinarily high. So today when people say AI, they're just talking about deep learning, but AI has a lot of other things. It is not deep learning alone. So if you look into the manufacturing facilities in the US, this is a distribution of manufacturing facilities. It is from Jeff Winter. And then where do small and medium manufacturers fit into this one? So you can, I think all of you can read English better than me. And like 98.4%, greater than 95%, all SMMs. And 85% of them have less than 20 employees. That is the takeaway from this particular slide. So if you want to have self-sufficiency, that we rely on our own country in order to be able to take care of our supply chains without any interruption, you cannot escape paying attention to the small and medium manufacturers. or in general, SMEs, etc., small and manufacturing enterprises. And this is in terms of looking at into the numbers, the employers are like about 240,000. These are the small and medium industries that constitutes to 98.3% of the manufacturers within the country. And then if you look at the payroll, and these slides are with you if anybody wants, please you can have them. Because you're not going to remember the numbers. I think you're going to remember the magnitude of the problem or magnitude of the landscape. And then if you look into the future of the smart manufacturing, because we are referring to the manufacturing enterprises. If you look at digital manufacturing, AI, and then human-centered and cybersecurity are some of the most important problems. This is from the national strategy on smart manufacturing. Then if you look into, this is from the national strategy, I just cut and paste from there. In tracing information on the supply chain, and then increasing the visibility of the supply chains, and then risk management, and what we call stimulate the agility of the supply chains are the most important problems in order for us to build resilience into the supply chain. And then by our view of manufacturing, in the earlier days it was mass production, and then we all know about this. And then it was customer driven, so this is built to order. The customer can be the size of one. And then the future is in terms of network centric. Everybody is going to be connected. Because is there anyone here without a smartphone? Zero, right? As long as you have a smartphone, I can connect to you. If I can connect to you, you are connected to the internet. Which would mean everybody can be connected to everybody. There are, I don't remember the exact numbers of how many smartphones are around in the world right now. So coming from that network, what is Industry 5.0? Everybody talks about Industry 5.0, and then there are several kinds of definitions. So you look at the Industry 1.0, steam engines and mass production, and then 2.0 is assembly line. This is from a paper, fairly nice paper from the Journal of Cloud Computing. And then the industrial automation system, SCADA and all that came in. Then digitization is still, I wouldn't argue that it's already done. No, it is only in its infantile stages. Digitization is not really has been accomplished, but the main focus of 4.0 is digitization. And then in the Industry 5.0, it is cyber physical systems. Cyber, your cell phone, you are connecting to the machine, that is one-way cyber physical system. And then you can have, and also you have cognition into them. You are connected, but also you are trying to put your thoughts in running the machine or running the supply chain. That's where AI would figure in. And have the green manufacturing, your lead program, right? That's how this is becoming an integral part of Industry 5.0. And because of the network nature of manufacturing or the world, you are looking into cultural collaborations and then mass customization. Remember, mass customization today is very different compared to earlier. Today, it is mass customization to a customer size of one. And future, this is a very busy slide, but I'm not going to read everything. And additive manufacturing is going to play an important role. So in 1999, we wrote a paper that future is like you're going to have kiosks in which you're going to do manufacturing. These kiosks can be run by anybody who have knowledge. And then, for example, you can have an AI machine in your kiosk or at your home basement, and then you can produce parts. So what happens, this is going to be extremely important. Another is sensors. You have a smartphone, you are a sensor. So I can get information from you. That is going to be an extremely critical one. And this is another, the human-machine interface. So I think, what is that movie, Tom Cruise's movie?
Mission Impossible.
Mission Impossible, and he stands in front and then they're trying to predict the future criminals, right?
Minority.
Oh, okay, well. So, I like to watch Bond movies. I can watch the same movie 10 times and don't get tired. My wife keeps telling, how can you watch it 10 times? Craziness has also has some kind of, I think, path. So I'm going to talk, I think I just quickly did this because most of you will know all these things, but the important things are the sensors, additive, and then workforce. From a purely technological point of view, quantum computing and all those things are going to play a major role. But today, I'm not going to be looking at quantum computing to help any small and medium industries. That will be a futile exercise. So here, my idea is like making SMEs in general smart, or in specific, the small and medium manufacturers smart. So one example here, this is something which we did. Maybe, yeah, so just to show that I'm not talking in abstract, but actually instrumented the machines with sensors. And also here I just showed the HVAC unit, and then instrumented with sensors here, especially vibration and sound, and then tried figuring out, okay, which kind of an IoT will help us. The common platforms are Raspberry Pi and NVIDIA Jetson Nano. So what we actually found out, which now people agree, we did it about 4 years back, is 3 years back, sorry. Jetson Nano is much better IoT than Raspberry Pi. Raspberry Pi is a little bit cheaper, but it is more stable. You can see the observations increase, and the time for calculating the Fourier transform in order to do sensor-based analysis, you can see it's very steady here, it is all random here. So if you really want to do a good sensor-based machine learning or data analytics, then you need to go with something like this. That is the takeaway from here. This is the part of Clean Energy Smart Manufacturing Innovation Institute. We had a major project for a year and a half with 3 universities together. And then this is a takeaway which they are using now today. And again, another thing, as a part of CISME, in fact, Pentep was also a partner for that with me, with the 10 of you. And this is, people talk about learning at the edge. What do you mean by learning at the edge? This can be a machine, that table can be another machine, that can be another machine. Each one have to be, they are all similar machines. I'm not taking grinding and milling and turning. They're separate, but they're all same machines. And they need not necessarily from the same manufacturer. If they are from the same manufacturer, wonderful. So basically what I would do, collect the sensor data, which I showed you in the front, in the previous slide. And then I try to learn. What am I trying to learn in a lathe? I'm trying to learn the quality of the product. How can I learn the quality of the product? By looking into the quality of the tool. How good is my tool, good, bad, or ugly, or on a continual basis, what is the tool wear, the radial wear. So I learn from here, I learn from here, I learn from here. I connect with the cloud and basically transfer this data. And then if a new machine comes in, which is doing the similar process, not similar, same process, then I can actually learn without knowing about that machine. I can predict what kind of quality the part is going to have. Those are the two cases. Third case, this is I'm doing for a company in a customer container solution. This is funded by, recently funded by what is it, PA Innovation Grant from the state. Yeah, run from Carnegie Mellon. They make these containers. This is customer container solutions, mouthful, CCS. And what we are trying to do is the welding defects. Okay, welding. The specialty of this particular company is that the fifth generation employees. Okay, like families work together, like worked in that particular company, and the operators are not very consistent in their skills. Why these defects happen? And they are not very knowledgeable because skilled labor is very difficult to get these days. And then the equipment may not have calibrated properly, and then the electrode can be defective, and then the material also can have problems. So the steel you are trying to weld together, and then there can be a lot of contamination on the surface without even cleaning it up. You may try to do the welding. So, and also very expensive. You can see that like you need to go through a lot of problems can happen. Okay. The integrity and then economic ramifications, safety and reputation. 2 times your product gets recalled, you're done. It's like you have a restaurant and then one day health inspector comes and shuts it down for a rat that he or she sees that, then you're done. Like same thing happens here. So this company which we contacted, which we connected with through Penta actually, they wanted an automated system to be built. That's where I went in. And this is done by me and my colleague, but so far most of the work is done by me. And then the idea here I had is not only that we build the automated defect analysis, therefore quality control system, but also to train workers with that. Okay, so that was the whole idea which we are exploring under the grant. So if you look at, let's say these are all the images, and then you can have the defects, and I can come up with these results. If the problem is porosity, or maybe this is a good, and then a good with this 0.631, 0.728 are probabilities. So higher the number, the better your judgment is. So, and what we did, I can show you here. You have the weld. We took a lot of photographs, and then essentially used deep learning. Today they have something called attention learning, okay, attention networks. What does attention networks do in principle? Let's say any image is a set of pixels, right? A set of pixels. You take a camera, and then when you buy a what you call 64 megapixels, don't buy a 64 megapixels. It is of no use. I won't say that. For this may be useful, but for taking photographs for us, if you cross 24, it's enough. That's very good. And I do photography on the side, so that's an advice. Here, what happens is, like, when we see things, we want, let's say we want to see people. Then we focus on, let's say there are animals here, and then there is grass, and then there are trees. But you're looking for people. So your brain focuses on the people. How does it focus? It takes this whole image, cuts into pieces, patches. And these your brain focuses on those patches and tries to remember. So that is used to say, okay, this is a person or not a person. This is defective or not defective. In principle, it is very straightforward, but computationally pretty rigorous. So we built a deep learning network to do this, so I can say good quality and defective quality out of this. And what we also did was, taking these images and defectives, I went into the large language models like the like ChatGPT, if you are familiar with that, you can ask questions. In Google you do search, but in ChatGPT you can ask questions and then it comes up with responses. Don't believe all the responses. So here we are trying to interface with this. Let's say there's a material problem, and then you can ask, automatically the system will go and then pull out information from ChatGPT and then try to give you all the characteristics of that particular material you are welding. So this is in fact this we did last 10 days back or so. So the 2 minutes I'll be done. Yeah. So, the future, the way I visualize is, let's say you have all these SMMs, so small and medium manufacturers. So I wanted to find out some basic problems they have. The SMMs are not even visible in the internet world. So I can go to Mergent database and then Dun and Bradstreet and then pull all the information about the small and medium industries. In this particular case, I focused on, because of that, I focused on the biopharma companies. And in Pennsylvania, there are about 700 of them. And then essentially I tried to represent them in a database. We found out a graph database is the greatest thing to do this representation. So the graph, what is a graph? Basically connecting people. Let's say myself and Krishna are friends, and therefore she is one node and I'm another node, I put a link. And I'm one manufacturer and then she is an R&D, I'm working with them, so I put a link. So like this I built this whole network. It's very complex in one way. And I want to search through, so we built a search mechanism. You ask any query, it can go give you. And then this is an interesting part. We try to do link prediction. What do you mean by link prediction? This is the network today, and then tomorrow one of you want to join this network, or 20 of you want to join this network. What is good for him here? Who is good to be connected with him? What is the highest probability of success of connecting to them? The rich get richer phenomena, if you want to call it. So here we built this link prediction, and then this is more from a machine learning point of view. What variables are important in this link prediction? Locality, or kind of business, or your reputation, things like that are obvious. And then we do a lot of graph-based metrics. How do you characterize the graph? And I think I'm going to reverse. This is, we're trying to standardize this. How do you do this? And then trying to build this standardization. So this is, I see as the future. And then I've been on national panels on manufacturing, and I could see that this is becoming how do you say, important, possibly important. And then this is the idea from Seismic Linear Smart Manufacturing. They are the ones who are working on future of AI. So at the edge, what needs to be done? Interoperability. So when I say standardization here, I want this system to be interoperable with everything else in the manufacturing. And then standards on the open control. So this is AIMI, and then there are 3 people I'm leading, but Greta does a lot of work, and Todd. And then our vision is help researchers develop AI and ML applications. And then we work with a lot of Commonwealth campuses before even, I think today it is becoming important. And if you're interested, there is the email. Thank you. Sorry for that.
So, Dr. Kumar, one question that I have that I think is probably bouncing around many of people out here. The director for the Center for the Applications of Artificial Intelligence and Machine Learning to Industry. We have a lot of manufacturers from Northeast Pennsylvania sitting in the room this morning. How do they interact with you and all the great stuff that you guys are doing at main campus. Could you answer that one question for them? And then at the break, you can come talk to them. We'll have more questions at the end. But how do we leverage all the greatness that you're talking about here? That's my one question.
Okay. I think we have a membership model, but is for large companies, that membership model is effective. However, with small and medium, small industries in specific, the membership model may not be like immediate, like large sum as a membership model is not the right thing to do. So what I am proposing, what I'm trying to drive the center towards is what for a nominal sum, that which you are trying to decide, maybe, I don't want to throw a number without, maybe we were playing around with like a $10,000 number. In that, the center will, if you have like 10 people coming together, 10 and 10 add together, you have 100, I can go, possibly some of the federal agencies will be able to help. So then that becomes multiplied, federal and state agencies, and then that is going to be used to solve that problem. So let us say, anybody here, let's say from a small and medium industry, please tell me what problem you have, whether we can even address it. Okay. Can somebody tell me what problem you have? Or you say no problem at all? Yeah. No, I think quality control can be a major problem. Worker retention can be a major problem. Worker training can be a major problem. And your access to supply chain can be another big problem. You come up with this, how do you do that? Then I think we'll be able to help. We have access to all the faculty on campus, and we have a good feel towards who can do what. So I think did it answer?
Fantastic, very good. So, all right, so Dr. Kamara is going to be here at break, and he'll be back again for the questions. We're going to do a quick change here. We're going to have Andy come up. So again, there's food and coffee outside through the back. You can get in and out. And any questions, hit me up. Great.
Actually, let me just say one thing.
I also wanted to mention there's a grant right now that's available through DCED. Dr. Kumar mentioned that's how the welding, the custom container solutions program was funded. It's a $70,000 grant that funds graduate student work to work with faculty together with manufacturers to help solve problems just like he described. And that is open, I think, until November 10th. And so it's a matching grant, but the match could be in kind. And so that could be faculty time, that could be staff time with your company. So if there's interest in that, please come see me after and I can help connect those dots.
I'm glad she mentioned that, Krista mentioned that, because that's a very good avenue, immediately available. I think can connect you with the faculty through the AIMI Center, and then you could work on a proposal. It's a short proposal.
Thank you, Santa. Okay, our next speaker this morning is Andy Gatto. Andy is the Innovation, Ecosystem, and Partnership Strategist for the Nittany AI Alliance. In this role, Andy focuses on the development and implementation of a partnership strategy to support Nittany AI's student-centered, artificial intelligence experiential learning initiatives. With an emphasis on collaborative partnerships, he develops relationships that leverage the strengths of the Penn State ecosystem and our network of industry and nonprofit partners to generate maximum value across the Nittany AI community. Andy graduated from Penn State in 2002 with a BS in Health Policy Administration and a minor in Information Sciences and Technology. Andy is going to discuss this morning the Nittany AI Alliance and its mission to address real-world problems through experiential learning projects using artificial intelligence-based solutions. Andy.
Cool, thank you. So, Nittany AI is really a program centered around experiential learning for students, but we exist at the intersection of industry, students, nonprofits, faculty partners. So we are really, truly an ecosystem built on partnerships. Our mission is really focused on giving these students an experience working with AI, but we wrap it in an umbrella of AI for good. So we want students thinking about the impact this technology can have. We want to enable solutions that have social impact, that impact the world, for good. So that's our mission statement. Why Nittany AI? We actually started in around 2017. We were called the EdTech Network, working with the World Campus to help World Campus stay ahead with technologies that were emerging in the market. But quickly zeroed in on AI because we felt AI is going to be we felt at that time it was going to be a transformative technology. It was going to impact absolutely every industry out there. Every vertical that you can think of is going to are going to be impacted by AI. So we wanted really all the students coming out of Penn State to have an experience working with AI. So we shifted quickly from looking at everything. We were looking at VR, AR, all sorts of different technologies to become the Nittany AI Alliance, which in hindsight, using the word Nittany has been interesting as we've traveled the country because we just assume as Penn Staters and people from Pennsylvania that everybody knows that word. And nobody outside of Pennsylvania who's not a football fan knows that word. And so we've toyed with dropping that from the name, but we all know what Nittany means, but you get outside of PA and it confuses people really quickly. So our model, the key characteristics of what we do. I am not an engineer, I'm not a scientist. Darren Poudre, who helped start this organization, he's an entrepreneur. He was the entrepreneur in residence with us. So we are not technologists. We work with folks like Soundar to keep us straight on the technology side. So we are looking at the application of AI when we talk to our students. We're asking them to look at problems around them. We work a lot with nonprofits to look at real world challenges that the nonprofits are facing. And then we look at existing tools and ways that we can apply the technology to solve some of those problems. Our group is small. We operate kind of like a startup within the beast that is Penn State, which that has its challenges when you're working in a large, we'll call it matrixed institution like Penn State, but we try to evolve quickly, we try to adapt to our partners and the needs that we see out there. We've built an innovation framework that we think has been really effective in pulling together our partners from industry with our students and our faculty to kind of drive some of these innovations forward, to look at proofs of concept where AI can be applied, to do these things quickly, and then to have off-ramps where they can go out of our program. So they're not just dead ends of a student project that just sits on a shelf somewhere. We're moving those into larger research applications. We're moving those into applications in the startup space. So we've built what we think is a really good collaborative model. And we try as best as we can in this big ecosystem of Penn State to be inclusive. We work with a lot of campus partners. I'm out of University Park. We're part of Penn State Outreach, which is based in University Park, but we have strong relationships with a number of campuses, and I really hope to grow that relationship here at Scranton. That's one of the goals I have today, is to meet some faculty from this campus and talk about ways to get faculty and students from Scranton involved in what we do. So key outcomes. So for students, obviously, we think of ourselves a bit as a career development program. Like I said, I often challenge folks to come up with an industry that we don't think will be impacted by AI, and I'm sure we can probably find an obscure example in there, but there's not many. Really, it is truly everywhere, so we want students understanding that and not trying to escape it or not being afraid of it, but getting some experience working with AI, because we know that will benefit them when they leave Penn State. Part of our outreach mission folds in nonprofits, so we have been running workshops around the state with nonprofits to surface challenges from within their organization, to educate them from a basic standpoint about data and AI and what those tools, where those applications are, to get them looking through an AI lens. We always say we're not going to turn anybody into an AI engineer or a computer scientist overnight, but we can get folks to look at the things around them through this lens of AI and data. From a faculty and industry standpoint, we really want to drive collaboration. We have a particular part of our model, which I'll talk about in a minute, where we drive these AI projects, we surface these real-world use cases, and we pull together partners from industry. Our model is supported in large part by our industry partners from a funding standpoint and technology standpoint. And then we bring in faculty as SMEs. SoundR has worked with us on a couple projects, one specifically with Goodwill as a partner. And we hope that those projects not only give the students an experience, but build relationships with faculty and industry that can lead to future relationship or future research opportunities, that really benefit everybody in that relationship. And then tangibly, from the industry standpoint, I would imagine, how many industry folks in here right now are hiring at some level? And I would imagine somewhere in there is data and AI and engineering skills that you're looking for. So we think we've created a truly strategic way to recruit talent. The getting away from the old school way where we all show up in the Jordan Center or some other large center and we're just exchanging pieces of paper and you're having 30-second conversations with somebody and then trying to make a decision to invest tens of thousands of dollars in onboarding and hiring them. We give folks an opportunity to get to know students over a long period of time, working with them in a real world environment, seeing how they operate, working through an agile process, interacting with clients, presenting. We've seen that impact, and I ran into somebody from Lockheed earlier, and Lockheed's been a great partner and hired a number of our students, many of them with offers in their junior year, which I always think is pretty exciting. So actually, yeah, there's Alan from Lockheed. I forgot we dropped his quote in the bottom there. Alan is out of Lockheed Space in King Prussia. So this is just kind of a quick visual on our model. We think of it like a funnel. So AI Inspire is really kind of an events focused. What is AI? We do different kind of webinars and hybrid virtual live events across University Park, but we extend those out to the campuses. That's really to kind of open students' minds to AI, that this is not just something that is aimed at the engineering students or the students from IST, that everyone should be thinking about that. And out of all those events, there's a call to action to form a team, find an idea that you're passionate about, and enter the Nittany AI Challenge. So the AI Challenge is open innovation, team-based competition that we run over 9 months. So there's an idea stage that we then kind of down select to a prototype stage and down select again to an MVP stage. And we start with around 75 to 80 ideas that are submitted, and by the time we reach the MVP stage, and the ideas are submitted in January, so January 31st, ideas will come in. They work on a prototype up until April, the teams that are selected, and then the final 10 on September, early in September, we just did this on the 7th and 8th of September, are on stage in front of an auditorium of folks from industry, leaders around Penn State, and they present MVPs, and then we down select, and there's a $50,000 prize pool for those students. The challenge does a couple things. It surfaces a lot of really interesting, innovative use cases of AI. One of which, in the last year, it was a grad student from the entomology department, created something called Insect Eye, a computer vision assisted tool for cataloging insect populations. And they just were awarded very recently a $3 million grant from NSF. So that's that kind of positive pull-through that we're seeing from our competition. But so it drives research, but it also helps us surface top talent. So we recruit from the challenge for our program called AI Advanced, where we hire interns that we manage, and we partner with industry and nonprofits on very specific projects that may come from industry who wants to see how do we kick the tires on this potential AI application. Not something from your core, obviously your kind of core R&D space, because you don't want to give that to a group of students no matter how talented they are, but something that's kind of out there maybe a little bit in left field where you can take a little bit of a risk and see what that proof of concept may be. So those are really our top students who enter advanced, partnered and funded by industry, and those are either solutions from industry or from nonprofits. And then AI Connect is really just our alumni program within our students, the way we stay connected to these rock stars, because they go off to great places. and I hope to develop relationships that they can come back and help support our programs. So Inspire, like I said, really just the top of our funnel. The output there is students who are fired up about learning more about AI and entering our ecosystem. The challenge, like I said, 9-month-long innovation, open innovation. We're actually considering right now a little bit of a shift in the model, so it may not be 9 months long because we want to line it up with the curriculum, with the semester cycle, because there's a lot of folks talking about AI curriculum development, and we want to be prepared to adapt to that. So we're considering changing that model a bit, but prototypes, proposals, minimum viable MVPs are really what we will come out of the challenge. In advance, like I said, the cream of the crop of our students working in real-world environments on AI proof of concept projects there. So the value back to industry in this case is that strategic recruiting tool, the relationship that you can build with faculty for potential future research relationships. So this is an example of a team that went through the challenge, and it kind of shows kind of the breadth of our exposure. This team was represented across 3 different colleges, 3 different campuses. We had multiple faculty, advisors, and mentors, and they were looking at the issues with transfer credits, which is a massive headache in the higher ed space. Just a lot of manual labor, taking out a lot of missed opportunities there. But this is a huge opportunity for whoever can solve it, and it's really, the more we've dug in, it's a tailor-made application of AI. And AIMI is a student who had worked with us, and she was hired in her junior year by Lockheed. This is a current AI advanced project that we've been working with SEPTA. So the trains and buses out of the Philly area. Again, a large number of students, because we've actually worked across a few semesters, because we started with them focused on one particular aspect of safety on their train platforms, leveraging their CCTV feeds. They wanted to see overcrowding on the platform, so our students developed a model that could give them a weight and detect when crowds exceeded a certain threshold. And from that, then they wanted to see falls on the tracks, and so the students adapted the model to detect falls, and that's been a really interesting evolution. And then this semester they're working on fare evasion. So they wanted to see two things: fare evasion and abandoned packages. So fare evasion of people jumping turnstiles has been a pretty interesting one for the students to try to figure out. And they're kind of leveraging some anomaly detection tools to do that. So that's kind of an ongoing relationship that we've had with SEPTA that's bearing some results, and we've had partners with AWS, or from AWS and Accenture helping along the way there, and Accenture has hired a few students out of these projects. And then Smart OCR is a good example of kind of internal innovation that we know our model can drive. So this is working with the admissions team at Penn State to address an existing problem there. And this is, again, a computer vision application that can look at incoming transcripts, sort that information, take away a lot of the manual labor that's done by that team, and they can, the pull through on those transcripts, we can really increase that speed. This one we've now worked on over the course of, I think we're into our 7th or 8th semester, and we've moved through the proof of concept stages, which is where our model always kind of stopped, and we had this off-ramp either into the Invent Penn State ecosystem as a startup or into future research like I explained before. This one has kept going because we know this is a major issue at Penn State and at a lot of the other Big Ten institutions that we recently met with who said, yes, you all should keep going, and we would be interested if you do and develop something that can actually be implemented. So we're working closely with the Cloud Computing Group, closely with Penn State IT, and this is actually an experiment to see can we go beyond proof into actually something that can be implemented. And a large partner has now come to the table to help us potentially enable that. So it's kind of exciting and could be a change to our model that we did not see coming. But yeah, so Smart OCR. And really that's the gist of our model. We are a partnership-driven model based around collaboration. We started student-focused, but realized that we had a lot of value to offer industry partners as well. So like I said, two of the things I wanted to accomplish today was one, to develop some relationships here in Scranton to hopefully get faculty and students from this campus working with us and entering the challenge and looking for innovative use cases. And also, if there's industry in the room who are interested in hiring talent in this space, we think we have a great model to engage with top talent and to build relationships with faculty like Soundar working on real projects. So I have cards. I thought I had a slide in here with my QR code up there. So Soundar beat me on the QR code with the cool one that you guys had up there. But I have cards, so if anybody's interested in learning more, please grab me and I can give you a card when we talk about deeper conversation. So thanks.
Great, thank you.
Yeah.
All right, so on our agenda, we actually consciously put in a break time right now. And so the thing that I'd like to say to you, first of all, I said at the beginning it was a gift that you guys made the effort to come out. Let's do some work now. Here's your opportunity. Grab a coffee, grab something to eat, introduce yourself to somebody that you've never met before, introduce yourself to somebody from U Park. Here's your chance to connect for a couple minutes. We're going to have you back at 10 after 10. We're going to finish it up, then we'll do our tours. But take advantage of the opportunity. The bathrooms are here in the back, but grab a coffee, say hello to somebody, make this worthwhile. As long as you came, make this worthwhile. Ask somebody a question, introduce yourself, talk to somebody from main campus. We're going to finish up, and we'll be back at 10 after 10. Okay? Great.
I'm
going to say is thank you for coming back. It means a lot. It really does for our speakers. So our next speaker this morning is Dr. Majid Jassez. Right? Thank you very much. And Majid holds a Bachelor's in Science in Mechanical Engineering from Gannon University and his PhD in Mechanical Engineering from Virginia Tech. Dr. Jassez has been engineering faculty at Penn State Scranton since 1987, teaching various engineering courses. Areas of concentration include solid mechanics, design, and stress analysis. Najib will provide an overview of Penn State Scranton's new mechanical engineering program and its manufacturing focus, faculty expertise, and how they are training their students to apply artificial intelligence and machine learning to industry. And I do invite anyone who hasn't seen the building to stay for the tour at the end because it's pretty amazing. Najib.
Thank you for attending this. Welcome, everybody. It's nice to have you here. Our College of Engineering at Penn State approved PSU Scranton to offer Bachelor of Science in Mechanical Engineering 2 years ago. This is a PSU College of Engineering 4-year mechanical engineering program. In June of 23, Accreditation Board for Engineering and Technology Commissioner visited the facilities, the faculty, program requirements, support system, and the students. In July, TEC of AIMI voted unanimously full accreditation of Penn State Scranton Mechanical Engineering as the second location of ME University Park. The curriculum covers the following technical courses: Calculus 1, Chemistry, Engineering Design. Second semester, typically students take a second calculus course. Mechanics, that's college physics, which covers mechanics. In the third semester, students take engineering mechanics, which is statics, differential equations. They take a second physics course, which is electricity and magnetism. They also take a computer programming course, which covers MATLAB. In the fourth semester, they take dynamics of solids, strength of materials, engineering thermodynamics, and 2 more math courses. One of them is vector analysis, the other is matrices. In the 5th semester, their junior year, they take a fluid dynamics course, mechanical design methodology, machine elements, and academic career development for half of the semester. That's the half-credit course. 6 semester courses include Industrial Engineering 312, which is manufacturing processes, material science course, that's material science and engineering. They take a computational method course, which is primarily usage of software in different areas of engineering. AIMI 348 is circuit analysis, instrumentation, and statistics. They take a vibration of mechanical systems and one more professional development course for half of the semester. AIMI 440 is their capstone design project in their senior year. Then they take mechatronics, which builds on instrumentation, circuit analysis, and it's basically fusion of electronics, mechanical engineering, computer coding, and some AI. That's what mechatronics is. Our AIMI program gives the student the option of taking 4 technical electives so they can concentrate in a given area of their interest. So typically they can choose one engineering technical elective, a general technical elective, and in their last semester they can take a mechanical engineering technical elective and another 400 level course from any other department as long as it is an engineering course. They also take heat transfer and mechanical engineering systems lab and feedback control system, which is called modeling of dynamic systems. So these are basically technical courses that our program covers. They also take 6 general education courses that I don't want to really talk about. It's very important to observe that at Penn State, we do not admit the student to a specific major. So if they are sure they want to go, say, for electrical or mechanical or whatever, we initially admit them to the College of Engineering as pre-major, and they have to meet 3 requirements to be admitted into the major of their choice. These are the 3 requirements. One of them is they have to be in their credit window, meaning they must have passed at least 29 Penn State earned credits. They must have passed chemistry, 1 college physics, 2 calculus courses, and an engineering design with at least grade of C or better. And their overall grade point average must be at least 2.6 or higher to be admitted into mechanical. Some other majors also have the same requirements, but with a different GPA. This table shows the number of our students. Generally, we used to offer the first 2 years of 12 engineering majors, and students used to do what we call 2+2. They would do 2 years here, go on to University Park to do the second 2 years. But since 2 years ago, when we offered Bachelor of Science in Mechanical Engineering, these are the students who start here and end here. When we started in the first year, we had 13 mechanical engineering students. Last fall, we had 24, and I'm happy that our program is growing very rapidly. This semester, we have 34 mechanical engineering students, and these numbers do not count the number of students who are in pre-major status. Well, we offer the following labs for our students. We have 2 physics labs, a computer lab that covers math lab and programming, engineering design, computer-aided drafting and modeling. They use SolidWorks as the software. Our manufacturing processes lab has a 2-hour lab every week. Computational methods is a course that was recently added to the mechanical engineering program. It's mostly, it's not a lecture-based course, it's mostly a lab-based course in which students use the engineering software like ANSYS or SolidWorks to do finite element analysis. Half of the semester, the students do work on solid mechanics, stress analysis, things on solid. The other half of the semester, they do work on thermal science issues, things that have to do with fluid mechanics or computational flow and things of that nature. AIMI 348 circuit analysis and instrumentation also has a 3-hour lab every week. Another course that has been recently added to the mechanical engineering program is AIMI 435. We used to offer 4 1-credit labs and students chose 2 out of the 4, but recently mechanical engineering department in consultation with industry decided to remove those 4 labs and offer a more comprehensive 3-credit lab, which is covering all those areas. It covers thermal sciences, fluid flows, heat transfer, material testing, and AI-related concepts like robotics and things like that. And mechatronics is another course that was recently added. It was added 2 years ago to the mechanical engineering program. Like I said, it's fusion of electronics, mechanical engineering, computer coding, and some artificial intelligence. And AIMI 440 is our capstone design course. And the campus offers the following support services to the students: advising center, learning tutoring services, disability services, career services, and we also have our engineering club. Students run it. They meet once a month. They decide what kind of activities they want to offer to other students, things like field trips, or we have invited speakers from industry. On this slide, I have our recently hired faculty, plus those who've been here before. We have Dr. Chaco. He has his PhD in mechanical engineering. He has 20 years of teaching experience, and his area of concentration is biomechanics, solids, finite element analysis, welding, and many other areas. We also have Dr. Farhang Danishmand. He has his PhD in mechanical engineering, PE certified engineer. He has 23 years of teaching experience. His area of concentration includes vibration, computational fluid dynamics, fluid-solid interactions, power plant, hydromechanical equipment, oil and gas industry. Then we have myself. My name, as I said, is Majid Chatsaz. It's hard to believe that it was 36 years ago when I started here. I have my area of concentration in mechanics, finite element analysis, thermofluid sciences, stress analysis, and computer simulation. We have Dr. Rahman. He has his PhD in mechanical engineering. He has 7 years of teaching experience. His area of concentration includes robotics, automation, manufacturing, instrumentation, AI, and machine learning. We have Professor Talsi. He has his Master of Science in Mechanical Engineering. He's a certified professional engineer in Pennsylvania, and his area of expertise is descriptive geometry, computer-aided drafting, and design. These are some of the projects, senior design capstone projects that students presented in the undergraduate research, which is held annually in late April. Professor Rahman was the advisor. So that was one of the projects, and they had poster sessions. They would explain the work they did and give relevant information to the attendees. That's another project, Professor Rahman. I don't know, are you here, Professor Rahman? If you wish to add anything, feel free to jump in, please. This is an intelligent solar system for hydroponic irrigation. That was another capstone project that participated in undergraduate research. And I think that was the last project they did. They presented 4 projects at undergraduate research. you want to say something
Oh,
about
yeah,
this? Well, this is a robot the students program to do AI-based manufacturing, parts assembly, sorting, and quality control. This is a robot that we recently purchased to be used in mechanical systems lab in spring of 24. And this is another nano robot to be used in different labs, instrumentation and mechanical system design lab. Industry connection. We have our industrial and professional advisory committee to discuss how the program stays updated with industry trends, internship opportunities. We discussed various things related to the program. The following individuals served on it: Mr. Jim Cook, Senior Manager from Gentex Corporation, Mr. Joseph Fenrock, I think I saw you a few minutes ago, thanks for coming. He's President of JKF Technologies. In Carbondale, we have Mr. Robert Marmot, Deputy Director of Production Engineering, Tobyhanna Army Depot. We have Mr. Brian Hart, Fabrication Manager from Lockheed Martin. I think I saw you a few minutes ago. Thank you for coming. We also have David Apolka, Senior Program Manager from Lockheed Martin. I remember I had David some 30 years ago as my student on this campus. Brian also, I don't remember, 20 years ago? I think 20 some years ago, he was my student. So it's a pleasure, sorry for this. John Durden, Associate Principal, Highland, and Associate, is another individual who serves on our advisory committee. And I want to take this opportunity to welcome any of you if you wish to serve on our IPAC committee. We really appreciate it. We meet once or maybe twice a year to discuss relevant issues about our program. So please let me know if you have interest in serving on this committee. Penn State AIMI graduates have the widest job opportunities in almost any industry, from aerospace to biomedical to even financial industry. I say mechanical engineering is the mother of all engineering majors because it exposes the student to almost anything, anything from aerospace to electrical to many different areas. So typical companies that have hired our students are Lockheed Martin, Gentex, General Dynamics, and Highland Associates. Our first group of graduates this past May were 9 students. 8 of them were employed and 1 of them continued to pursue a master's degree. Well, our hope is to have stronger ties with industry and do more collaboration in future. So I appreciate any idea that you want to give us, any advice that you might want to give us. And I want to hear what the needs of industry are and what you can help us with. So let us know whatever advice you have for us, we'll appreciate it. Any questions, or do we?
Actually, I have a question. Would you do me a favor?
Sure.
Can you go backwards in your presentation? Can you find that table with the students? While he's doing that, I'm just curious, how many of you, this is the first time you've been to this building?
Which one?
The one with the table with the students that have numbers.
Oh, okay.
So, for those of us who are from Northeast Pennsylvania, isn't one of the things that's most amazing is the hidden gems that we don't talk enough about as a region? This building, this program, this, you know, there's so much good stuff going on here. This is actually, Majid, would you help me with this, please?
Sure.
So, I have a feeling I'm not the only one that exactly knows how many, but, all right, how many engineering students do you have? This is a brand new program. Congratulations, it's amazing. How many active engineering students do we have right now?
Total or mechanical?
Total.
Total 117
Okay,
as
so we
of last week.
117 engineering majors. This is a new program, so a new 117, of which, of the 117, 34 mechanical? Is that
34 officially are in mechanical, but out of these, many of them, they haven't gone through the entrance to major process, so this number will be, I don't know how much, but more than what it is.
Okay, so if we have 117 engineering students, how many of them are ready for internships in industry? 117, right?
At least half of them are already qualified to do many jobs out there. But the ones that are freshmen, maybe you want to give them a couple of semesters before they can go to any internship opportunity.
So of the 34, what are they, rising seniors, rising juniors kind of thing?
About maybe 12 of them are seniors who will graduate this coming May,
Right.
and the rest of them are junior and sophomore.
Okay, great. So that represents a whole host of internship opportunities that maybe you as employers may not have been aware of. And that's actually the point that I wanted to make, right? So very good. All right, so again, what we're going to do is we're going to have Fred come up and finish his remarks. Then we're going to open this up for all sorts of questions. And then for those of you, with all of you who raised your hands, if you want to see what's actually going on, that's what we're going to do at the end. Right? Rajiv, thank you so much.
Thank you.
Jack.
To your side.
While Don's getting ready, real quick, I wanted to ask the crowd, how many of you have an active ChatGPT account? Everybody take a good look around real quick. How many of you, with your hands up, have ChatGPT installed on your phone? Okay. That's interesting.
All right, so this is Fred Abley, known as Mr. Fred to his students. Fred is a Penn State graduate, right, Fred?
Yes.
Right? And he is the IST IT program coordinator that oversees internships and outreach for Penn State Scranton. So, Rajiv,
AI switch.
kind of like Tom Hanks, right? When Fred's not teaching a variety of technology courses, he's involved with local industry via the Penn State Scranton Launchbox, where they connect students to real-world problems. Fred's going to talk this morning on the highlights of Penn State Scranton's information technology program and its engaged learning objectives.
Thank you, Don. Good morning, everybody. I'm going to talk about a little bit more of the intake side of this and my role as an internship coordinator, but I'm also a faculty member and I'm a student advisor here at the campus. And as everyone's sharing their years of service, this is my 25th year here, and I never thought I'd be here this long. So it's my background is former military, software developer, and also faculty here. And my students are also now moving into the AI component. So I'm going to try to explain to you a little bit of a difference. The one thing that you're going to notice about Penn State in general, not all the programs are the same in terms of their structure. In particular, my program that I'm in IST, Information Sciences and Technology, and we also have a new degree called IT, which I'm going to focus on here. The IT degree can only be completed at a branch campus, at a Commonwealth campus. So that confuses some people a little bit. Some degree programs, if you're a parent, you may already know this, some degree programs do not require a student to do a co-op or an internship. That's a really good shopping tip as your young person's going towards college, because it is a key component. However, every student can do an internship. There's a little bit of a misnomer with that sometimes. So what I'd like to do is just here's my real contact information. I don't have my QR code up there. So if you do have a question about internships, projects, and how we're connected to the Penn State Launchbox, please email me, call me, stop by and visit anytime. So what I'm going to go over now is the IT degree, which rolled out formally about 2 years ago. It was in response to some changes in the industry, but also wanted to be more responsive to the needs of the region. IST, which I was originally brought on to teach, has been around for a long time. We've produced many wonderful graduates, a lot of great careers and so on, but we still felt like we needed to change up some things. I'm not going to go into a lot of the curriculum details, but if I were to say what's the difference between IST and IT, IT doesn't require 3 years of a foreign language. Even though my students all want to claim Java as their foreign language, you can't do that. The point being, this is what it is. So it has 4 options in it currently. An application development option, where it's more like software development. It's more like a Java track. A lot of Java intensive work in there because it's cross-platform, it can go anyway. We have a business applications track. Now this one sometimes comes across as being soft, but this is more like an integration concept. So students working with business problems, understanding how the technology could be applied. We're going to probably see AI concepts strongly appearing in here as businesses come forward with their needs. Cybersecurity. I don't think I need to explain that too much, but that's a growing field. It's probably our hottest draw for students because it's the sexiest title. When you say business applications to an 18-year-old, you get a little bit of a deer in the headlight look. Cybersecurity continues to grow. Cybersecurity is also fragmenting from the standpoint of there's still deep research, there's an applied track, but now what we're starting to notice is that there's a splintering of checklisting, if you want, like a security risk analysis type approach. Last but not least is a custom option. We could sit down with a student that has a more clarified vision of where they see themselves going, and we could work with them as they blend in other program components, whether it's in engineering, IT, nursing, it could be a variety of areas. I tend to see more of the adult learner, the non-traditional student, looking at that kind of reinvention of the degree program. So these are the 4 options that exist in the IT degree that could be done in their entirety here. So how do you, as business owners and industry leaders, connect with us to get to our students? That's probably the biggest question. So if there's a need for a student to come aboard, we could do internships, or what we could do is what we call, inside of Penn State, engaged scholarship. You would probably just call them projects, right? So the 2 of them are different. The internships right here, though, is purely, it's an academic experience, meaning they're going to get a grade out of it. It's in a mentored environment, which is also kind of key. It's not really looked at as you bring them in and let them figure it out. We try to avoid those situations if we could. Just some of the mechanical, that's a 3, not a 5, but it's a 300-hour event. And the reason why I share that, detail is that it could begin and end almost any time during a year, and it could roll over months. It could start in the summer and roll into the fall. It could start in the fall and go into the spring. It could start in the fall and go into the summer. However, those 300 hours could be completed within 1 year, 1 academic year. And then the other big question that I tend to get is it paid or unpaid? So I've had averages of internships from $0 to $27 an hour. So it depends on the industry, it depends on the need. The one thing I will tell you though is if you're a smaller, medium-sized business, there are funding sources, and I know there's some other people in this room who are more acquainted or more knowledgeable with what those values are in those processes, but there is funding, there's matching funding available through a variety of resources that I would encourage you to take a look at. Students understand they need that experience. They need in our degree program it's required. But that doesn't mean that they grab everything. They go where they can make money and get experience because they have some challenges. So that's where if you can't pay them an hourly rate, you can offer a stipend. Something that pays for gas or anything that's maybe in their workspace. And then last but not least is unpaid. And that even could be parlayed into a couple different things. So one of the things we always strive for is minimal administration. I've had interns when I was a software developer. I noted that some folks shy away from this, especially if you're a small or medium-sized business, because you feel like now you got to do hand-holding and babysitting. Well, we also give you a little bit of structure, and you can bring them in as long as you're mentoring them and giving them that, that experience where they're interacting with customers on a real project. Contrary or counter to the internship, well, if you do have a project, an engaged scholarship, you can come in and have students work on a project. And that's really a great conversation that can start with me. You can contact me if you have an idea, and then we can frame it up, and then we start to understand how it fits into the time frame of a semester. That's probably the biggest confining element, is that, is it going to be 15 weeks, is it 10 weeks? Is it something, Andy, you were talking about, you don't want them in a core business project, but you might have some stuff on the shelves. One of the ones that comes to mind, as I'm just sharing this story, or this portion, we had students who were really eager to do more software development on their own, at night, on the campus. They were a great team to work with. They were a lot of fun. Texting me at 2 in the morning wasn't always a good idea, but they would do some great things. Well, we ended up introducing them to one of the companies that was up in Tech Ridge, and they said, hey, we have some technology we'd like some kids to poke around and play with. And sure enough, they did. They explored it. They got a lot of great experience. And then they actually used it a little later on in a research fair. So a lot of things can happen along those lines that you could benefit from. So that's an individual effort. You could have a student come in and do a project. Or a class project, which I'll give you an example of what I do and what I've done here recently. So you can run it as a project that you can inject into a course during the spring or the summer or the fall, and it would be led by a faculty member. So one of the examples, this is the most recent one that we did. In the fall right now, we have a class where the students are focusing on usability engineering, focusing on the user interface, the UX, the UI side of software. So we've worked with on multiple occasions. In this example here is the Guide app. This is Pat Sandone's company that's out working on a wellness app for first responders. And we set up project teams. We work with the engineers from his company, and then we begin to do our work, and then we have the students present the work back. What's really neat about that is the fact that you're getting insight from an angle that you might not be thinking about. Students bring, as you probably know, bring a very, very interesting angle that we sometimes don't see or we're blind to. And that's where a lot of our project work has helped other companies uncover some gaps, I guess you could say. So internship-wise, one of the things I'm really proud of is always to share this list. This is all of our students who have come to our campus and have completed their internships all around the region, the country, and in some cases the globe. So that's going to what Don was saying before. We need to do a better job of kind of promoting this, because we are that entry point for a lot of young people that end up taking their careers in many different directions. So that is our program in a nutshell. And if there's anything I could do for you to even answer questions and once again help you maybe think out an idea, reach out to me and I'll help you. And if it's not going to happen in my space, I know the other faculty member departments where we can even talk.
So as we bring John up, how many IST students are in the program? Same question as with Majid before. How many undergrads? How many rising seniors? Give our guests today a sense of how many people are in your program.
So in our IST IT program, we're at 130. And students that'll stay here for all 4 years, we're right around the 55 mark. And then as far as rising seniors, I'm not sure what our senior census data looks like, but on average, we're in the neighborhood of 35 to 45 graduates, seniors from this campus every year.
Another hidden gem, right? We're all looking for talent. It's on this campus. So John, come on up. Fred, thank you so much.
Thank you.
That's you. That's me. Holy cow.
And to wrap up our program today before we go to questions is John Drake, the director, the Center of Business Development and Community Outreach, and another of my good friends on the Penn State campus. So John.
Absolutely. Yeah, good morning. Center for Business Development and Community Outreach, long name. Basically, we sum it down to the fact that we serve as the bridge between the local community, Northeast PA, Penn State Scranton, Penn State as a whole, and our partners. Two-way street, we're reaching out, but we want people to reach into us as well. Fred just mentioned as far as internships, project-based learning experiences. We reach out to companies when we have a faculty says, I want to integrate a project into my class. We have companies that contact us and we find a faculty member. Sometimes it's hard for people to remember everyone that they listen to. You might lose one of the professor's contact information or can't remember their name or whatever. All you know is you want to contact them, contact us. We will connect them with you for, again, those internships. And it doesn't have to be actually a capstone program, right? It could be integrated into various levels. So depending on what your need is, and then we find the appropriate level for the classes. Research partnerships, same thing, whether it be here or research through one of our professors at another campus or at UPark, depending on their specialty. Technical assistant program, of course we think PenTap right away. But it might be something too, a few years ago we had something, someone called me up and said, John, I have a problem in the manufacturing process. Do you know anyone that could help us out? We have polymers that we cannot get to bind together. I said, let me check. 2.5 days, found a professor at UPark that did research on the exact thing, had the solution. We were able to team them up. So again, by using all of our resources, we try to help as many people as we can. Entrepreneurship, Fred mentioned we have it's called Scranton Launchbox. It's located at 611 Cedar Avenue. It's a free entrepreneur help center. Fred is one of our team members, and what we do is we provide free consulting. Most of our clients come in and they just walk through the door and say, I have this idea, you might think I'm crazy, but I think I'd like to start a business or develop this project. So if you know anybody that's in that realm, send them our way as well. Continuing education, we're also responsible for all short-term programs, credit, non-credit. If it's not a degree program, it goes through our office. We do customized corporate training, so if there's a need to develop your employees in a certain area, we can do that either here on campus or on site at your location. And then to round out our public programs, we also do youth programs, we do SAT prep, things like that, but we also run summer camp. We had about 300 registrations this year. It was fun. It was good to have the kids back on campus again after the whole pandemic, and they had fun, we had fun watching them. Here, this is just a sample. I figured I'd give you some of our public programs. There's information out on the table as well. And Scranton Outreach at psu.edu. So if you remember that, you can get to pretty much anything at Penn State. And I just want to mention too, if you contact us and maybe it's not the fit or maybe we work some, like Don, right? He's a great partner of ours. We reach out outside of Penn State as well. So if you remember that, scrantonoutreach.psu.edu, you'll reach myself, Joanne, or Allison. We'll try to help you out. So
Okay, so we talked about doing a tour at the end. Are you the tour guy?
I think Wajid is going to.
Okay, so if you're interested in the tour of the building at the end, Wajid, how about we stay right here and everybody come up here, all right? So one thing that I'd like to ask each of you is what's one thing you learned today? Take a breath for a second. What's one thing you learned today? You made the effort to come. What's one thing you learned? Just think about that. The second piece of this is we have all our speakers. If you have a question, somebody else is probably thinking it. So I'm interested in any questions for our speakers on anything having to do with what you heard today or anything else. But who would like to ask a question of one of our speakers?
The last speaker, Fred, I believe, you asked about GPT, ChatGPT.
Mm-hmm.
What was your point of that?
So,
I was wondering that too.
so I just came back from a workshop and one of our keynote, well, several elements were AI focused, and it was around 50 startup ventures. 5 people only knew of it.
Oh, really?
Yeah, so one of the things I think is interesting about that is we're all seeing it, some of us are fearing it, but maybe that's unfounded. But the thing is also the fact that we're in that knowledge bubble. We shouldn't be assuming certain things, and we should be making sure that, like Don was saying, there's a better communication about it to clarify these things, and talking with people who are leading in the industry here. Because there's there's a lot of opportunity. There's a tremendous amount of opportunity, and I think we're caught up in the Hollywood version of it right now, and I think that's dangerous.
Just one fun thing about GPT, I just learned over the weekend, one of my nephews, he ran out of ideas for stories to tell his children, so now he just types in bear, stream, random things, and he gets this and he reads it to them, they think he's wonderful.
Yes, in the back.
I have a question for Professor Kamara. Are you still there?
Yep.
All right. So, if you're somewhere between, say, Industry 2.0 and 3.0, say 2.5, how would you build that base to get yourself to 4 or 5?
I'm trying to see if my brain,
So let me
because
ask.
of anything I've done in the past, this space.
So we've done a lot of work in the past couple of years trying to put sensors into equipment that was previously all manual, and we're doing more work to that. But if we want to get to Industry 5.0, we need to be able to get that data and put it in a usable form. And I'm wondering if you have any thoughts on the best way to go about doing that sort of pre-work.
Okay, you are possibly talking to one of the best who can do that. Okay, I'm arrogant about it. The first thing is to see what kind of applications you want to run. Okay, like when you build a database, you think about, okay, what are the things I'm going to cater to? So using that as a basis, you try to identify which sensors are giving you what information. So at the sensor level, you may be picking up shop floor information. And then, whereas at the highest level, you may be connecting it to ERP to do things. Or maybe you send it to your payroll so that you know how much a person is working on a particular mission and what is the productivity, and hence you can do incentives for the person. So I think the first thing I would do is figure out what applications you need. That will give you an idea about your data storage and then your what you call bandwidth that you would be needed within the communications, and the what you call response times that would be needed for even doing things or connecting. Second thing I would do is interoperability. That is very critical. You may build something, and I showed you that SMA web. I built this very beautiful database, what do you call it, dynamic graph database. But it has to operate with everything else, so standardization is important. Earlier, in the machine level, SCADA systems help you a lot, but that is what you have to think about. The second one. Third one is if you're going to go to Industry 5.0, it is not like a jump. You need to be progressive. So you want to ask what kind of AI tools you're going to incorporate. AI today, like in a lot of AI, is part of things. You don't even recognize that AI is part of it. So I would start with applications, data that you are collecting, and then your volumes of data, and then what kind of decision-making things you're going to do, and hence what AI tools you need. That will be progression.
We'll talk afterwards. I think I want to connect you with someone in our facility.
Yeah, sure.
I think the other dimension is to potentially bring that question to Majid and his advisory board, where you can talk to other members of the community about where are they in the process of 2 to 5, and then is it a function of, this is an opportunity to work with someone like this at the AIMI lab, right? So really great question, because I think a lot of people are wondering, how do I get to 5?
It is a two-way street. It is also an opportunity for me to work with you and for the other people.
Right.
It is not one way. I'm not a consultant who will say you have to come to me. No. I think this is a knowledge transfer. Why am I able to answer some questions you asked me? Is I have done things with companies, and therefore I collected that knowledge. I see this as a continuous learning process.
Excellent question, thanks. Ken?
Yeah, it's not a question, but just to make sure you know who Ben Franklin's program is. So I'm Ken Okrepke, the regional manager for Ben Franklin Technology Partners of Northeastern Pennsylvania. One of the things we can do is support projects like the ones we're talking about. So it's not, or do you work with Penn Tap or do you work with Ben Franklin, you work with both of us. So essentially, if you wanted to put a project together with the professor here, the doctor here, we could essentially offset the cost of that project by up to $50,000 as a grant, and to help make that activity happen. So we work with a number of companies. I see people in the room from Gentex to SHOT to PSA. So we've had projects, recent projects here that have been pretty successful. So just wanted to make sure you knew we were out there. But again, work with Penn Tap, work with Ben Franklin. We're both funded by the Commonwealth to help you be as successful as possible. So where do I fit? It's process improvements and product development projects. That's where we fit. That's where we go. And so if you have something you want to do, work with them, work with us, and we'd be happy to help you out. So just a little public service announcement.
I think they got the real answer.
Who else has a question?
I'll toss one to Sandra. I would love to pick your brain on something. So what was staggering to me was the graph diagram. Yeah, the graph diagram that you showed up there about the volume of small, medium-sized businesses. As AI grows, we're aware of the fact that there's a power consumption. Do you have any concern about any risk windows as we either directly use AI or indirectly use it through applications that may be using AI that we don't know about in the not so much in the personal space, but in the corporate space that can create, for lack of a better word, outages? Do you see us, because there's the infrastructure piece of power, that's what are you seeing anything, are we addressing that properly in this country, or is that something we need to be mindful of as we move forward and get the right people talking about it, because we're going to be short
I think
staffed.
people are talking about the energy part of it, because the green computing looks into this particular aspect. I do not know the details of who is exactly doing it, but on the other hand, for the large language models, they are the powerhouse. So how does this large language models operate? They are adding, for example, words, and then trying to see your attention onto those particular words, the combination of words, and say, does it answer your question? Okay, that's how large language models operate. In the worst case, you can scan thousands of words and say, this is what is addressing your concern. So there are people who are working on making algorithms better, so that you don't need to look at all the thousands. So there's going to be an algorithmic push, there's a hardware push.
Okay. Like there was in the 80s or the 90s with software in general, right? We had software languages that we wrote that were very efficient, and then we had very limited hardware, and then we managed to create more hardware to require us to be less efficient. I guess.
So now you have all the embedded systems in which hardware and software have to come together. The programming style is very different.
Right.
My first programming was in BASIC, then I did Fortran, and then I did Pascal, Lisp. I can give you a list.
Right.
And then my students asked me, grad students asked me, looking at my gray hair, why don't you just get your old notes and then teach? I said, no, I don't use my old notes. I think I use for basic foundation, but everything is improving because I teach machine learning. I need to be up to date. I just tell them I meditate, so the answers come to me.
Thank you.
Any other questions? All right, then on behalf of all of our speakers, I want to thank everybody for coming today. For those of you who would like to see what's going on in this great building, come on up front, and Regine will be doing a tour. Everybody else, thank you so much for spending time with us today. Really appreciate it.